Good afternoon, and thank you once again for joining us for a webinar. Today, Teledyne Tekmar is proud to present the third in a series of presentations for you. And today's presentation is going to be Trends in Drinking Water Methodologies for VOCs. The EPA is currently in the process of developing a new revision for EPA Method 524.2. And we're going to discuss that in some detail today. Now, this research was conducted to revise the current list of analytes by deleting some of the poor performers and by adding emerging contaminants such as iodinated trihalomethanes and fuel oxygenates to the current list. Some additional goals for revising this method were to include things such as developing criteria that would permit the laboratories to modify current prescriptive portions of the method. This would be allowed while they were still able to maintain good data quality. They also did some research to evaluate tandem purge and trap concentrators interfacing to a single gas chromatograph. This would help to increase the sample throughput. In 524.2, many of you will know that this is not permitted. They also wanted to revise the current preservation scheme so that it did not include employing hydrochloric acid, which can be a concern in the laboratory setting. Now, currently, the U.S. EPA Office of Groundwater and Drinking Water at the Auburn facility here in Cincinnati, Ohio, was kind enough to share their findings for my presentation today, and I would like to thank them for that. Now, much of the data collected today that's going to be presented was from the EPA and was collected through the use of our Teledyne Tekmar Stratum PTC, which is our current purge and trap concentrator on the market. Now, today's presentation is going to cover a comparison of 524.2 as it's written today and compare it to the newly proposed 524.3. Today, I'd like to discuss instrumentation as well as changes for GC columns according to some suggestions offered by the U.S. EPA, as well as going over the newly proposed target analyte list, which, as I mentioned before, is going to include possible deletions and additions to the current list of target analytes. I'd also like to discuss purge efficiency and overall efficiency studies. Now, the EPA did both studies, and I'm going to present that data to you today, as well as some studies we did in-house on the Stratum PTC for purge efficiency. I'd like to also go into detail for the new preservation scheme that has been proposed, and I'll outline details of that. And then I'd like to wrap up today's presentation with final suggestions for method optimization. Now, the newly proposed method 524.3 came about for many reasons. First of all, they had recommendations to remove compounds from 524.2 that included poor purge efficiency performers. Some of the current target analytes were of lesser environmental interest. And secondly, suggestions to add to the target list were made to include some new emerging contaminants, such as your iodinated trihalomethanes, and they also wanted to expand that list out a little bit by including the fuel oxygenates. The development of procedures and modifications of method criteria to permit additional method flexibility without compromising that data quality was a great concern for the EPA. And like I said, I'd like to discuss that later in this presentation. Now, again, for laboratory safety and disposal reasons, a new preservation scheme that does not employ that hydrochloric acid as a biocide was further investigated and proposed. And then lastly, as I mentioned, An increased need for sample throughput in the lab was a primary driving tool to validate the possibility for these tandem concentrators. And I would like to mention that their investigation did employ the use of 2 stratum Purge and trap concentrators. Now, several major changes have been proposed for method 524.3 as a result of EPA's research findings. For example, as you notice here on the screen, there are 3 new internal standards that have been added. Now, for 524.2, there was 1 internal standard, and that was fluorobenzene. Now, for 524.3, the proposed changes for the internal standards have been 1,4-difluorobenzene, fluorobenzene D5, and 1,4-difluorobenzene D4. They've also investigated the use of different traps that had not been previously available when that earlier method was published, and they have included that in the new revision. They've also made some mention of new column and instrument recommendations and conditions that may be permissible. And this is because of the new updated reflections on the state-of-the-art techniques available for both GCMS as well as Purge and trap concentrators now available. Now, in method 524.2, if you remember, there were 2 surrogates that were used. 4-bromofluorobenzene and 1,2-difluorobenzene D4. Now, with this newly revised 524.3, it's been proposed that an additional surrogate be added. And this was because it's related to the oxygenated analytes. So now there are going to be 3, or it's been suggested 3 surrogates. And those are going to include a deuterated MPBE, 4-bromofluorobenzene, and 1,2-difluorobenzene D4. Now again, since the safety of field and laboratory personnel is always of interest, that new preservation scheme that I keep mentioning has been put into place and investigated with the current method parameters. Currently, 524.2 utilizes hydrochloric acid, which is a highly caustic material and not really an optimum choice. So therefore, it's been suggested that they remove that HCl from their current scheme and replace it with maleic acid and ascorbic acid. You'll notice from the screen that there have also been some changes to the BFB criteria for tune. Now, the strict tune requirements for 524.2 included that BFB tune every 12 hours. Now, it's been suggested that this criteria should change to permit in 524.3 a BFB tune with each initial calibration only. Also, I'd like to wrap up with this method comparison by mentioning that in 524.2, there was little regard to water management, or at least mention of it in 524.2. And a water management system in 524.3 is suggested, and it's also commented on to special parameters and recommendations on how to optimize your sample analysis using current water management techniques that are now available out in the workplace. And they even make recommendations as to 2 different types of concentrators with this water management system, specifically noting that the stratum PTC was a good performer with water management. Now, given the ability of a wider choice in columns in the marketplace, and along with the potential speed enhancements that are now available, EPA felt the need to investigate these columns along with split ratios. So they evaluated both of these at the beginning of the study. And again, this study was done here in Cincinnati, Ohio at the EPA facility in the Auburn facility. Now, EPA's goal was to choose the configuration that provided the best precision, detection limits, and the ability to withstand water interference. They were also looking to improve peak shape for all the newly proposed target analytes. Now, several 0.18 millimeter ID VOA columns were evaluated. and using split ratios of 40 to 1, 80 to 1, followed by a comparison of several 0.25 millimeter ID columns were compared. And those split ratios were 20 to 1, 25, 35, and 40 to 1. Again, for this investigation and comparison, the evaluation criteria included precision, peak shape, and that signal-to-noise ratio and detection limit estimates. Now you'll notice on your screen that these are the conditions selected for the research studies based on the performance criteria that I just mentioned to you. Now 2 concentrators from separate vendors were interfaced to the GCMS for all of these studies. I'm very proud to mention that Teledyne Tekmar's Stratum PPC was selected as one of the participants in this study, and that was because of its new proprietary number 9 trap, along with a unique water management system. Now, EPA's secondary goal of this research was to develop procedures for using tandem purge and trap concentrators. Again, interfacing 2 concentrators to its single GCMS system to improve that sample throughput and productivity in your lab. Now here I have a nice diagram for you so you can fully understand how this tandem concentration works. Now EPA used Teledyne Tekmar's instruments. Here you'll notice using Teledyne Tekmar's Duet high throughput interface system that the sample paths of these 2 Tekmar concentrators are interfaced by connecting the internal 6-port valves by use of the heated transfer lines. As depicted here in this illustration, you can see when the valve of one concentrator is in that desorb position, the other is in the standby or bake position, simply providing a heat conduit to that GC injection port. Now that second concentrator can advance to the purge mode while the other one is baking. Now this benefits because this reduces the total cycle time, and EPA studies confirm that it decreased that cycle time from 30 to approximately 19 minutes by increasing that sample throughput. Now with the proposed changes for method 5243, the use of these tandem concentrators will allow 2 of our concentrators to be connected to that single GCMS system through use, as I mentioned before, of the Duet high throughput tandem concentrator system. Now here I've included a picture of when I was doing a Duet study. You'll see that I have 2 Stratum PPCs that were connected to 2 Solitech 72 water and soil auto samplers, and they're interfaced over to an Agilent GCMS system. Here is a table that outlines the standard purge and trap conditions that were used for the research collected at the US EPA, again using the Stratum PPC. Now these parameters follow closely to Tekmar's recommendations. That short desorb time of 1 minute is possible due to operation of the GC in the split mode. This provides approximately 30 mils per minute of that desorb flow. Note here that a procedural calibration is used, which includes the preservatives. One concentrator in their study featured a moisture control module, also known as an MCM, and one concentrator did not, meaning this system was simply bypassed. Now this comparison allowed the EPA to study the effect of this technique on overall system performance. Now these are 15 compounds that have been proposed for deletion from the current method for 524.2 by the US EPA. Now this list came from a presentation that EPA provided at NEMC last year. This recommendation was based on the measured purge efficiencies in reagent water, and it's shown in the table here, together along with historical occurrence data. Now none of these compounds, you should note, are regulated in drinking water, and only that acrylonitrile is a suspected carcinogen. So you can see why a lot of these have been deleted from the current methodology. Now here are 14 compounds that they have proposed to add to the current method. These have emerged as compounds of interest since that last revision. In particular, you should notice the addition of those iodinated trihalomethanes that I mentioned earlier in the presentation, along with the addition of the fuel oxygenates. Now, the iodinated trihalomethanes are a relatively recently identified family of disinfection byproducts, and they could pose a carcinogenic risk similar to their chlorinated counterparts. So that's why they've been included as possible additions to the list. Now, the fuel oxygenates, which are present in reformulated gasolines, are introduced into the ground water by leaking from those underground storage tanks and are more invasive than the major constituents of gasoline itself because of their high water solubility. So, of course, with that information, you can see why they chose to definitely try to include as many of those as possible in the proposed 524.3. Now, the measurement of purge efficiencies and overall recovery through that sample path was an extremely important component of EPA's early research efforts. During the next few slides, I'd like to briefly discuss how these efficiencies were determined. And I'd like to also present some data and some conclusions. Again, I'd like to point out that a good majority of this data was provided by the EPA here in Cincinnati, and it was used and collected utilizing the Stratum PTC along with our auto sampler. Now, a comparison study of the purge efficiencies was performed in-house here at Teledyne Tekmar as well, and compared to the overall efficiencies that were collected at the EPA. So kind of a short second lab validation of purge efficiencies, if you will. Now, this presentation and data can be available to you later upon request, as I presented this data myself at NEMC last year. So it is available in a poster format for you that we'd be happy to send out to you upon request. So feel free to contact us at the end of this presentation or simply mention that you'd like to get a copy of that, and we'll be happy to forward that to you. Now, overall efficiencies were determined by comparing purged samples at 20 micrograms per liter with an equivalent mass of the analyte injected directly into that GC injection port. Now, overall efficiencies include losses due to that transmission through that sample path, and it's expected to be slightly lower than the purge efficiency because of that. Now, this injection was performed while a reagent water sample was desorbing over to the GEC. And this was so that the amount of water in the system during calibration was identical to a sample run. EPA used a plunger and needle syringe to calculate and to run these measurements. Now, this table is part of that NEMC presentation that I previously referenced to you moments ago. Now, it's a little bit hard to see, but if you can take a look at this, you should note that the results for this analysis were very impressive. The percent recovery for all target analytes that were analyzed were at approximately 90% or higher. Now, those RSD values were excellent and well below that 10% range. Again, we'd be more than happy to provide you with a copy of this data upon request. This does include the method parameters that I used for this analysis, and it also presents a general presentation of purge efficiency compared to those EPA overall efficiencies in a nice table format for you. Now, this slide compares the average purge efficiency for all of the analytes investigated at 3 purge temperatures. Now, the sample was heated through use of the Stratum PTC sample heater. And I'd like to mention that this sample heater does not come into contact with the sample and provides uniform heating around the entire sample vessel. Now, these purge efficiencies increase slightly with purge temperature. But this data seems to indicate that the precision may be optimized around 40 degrees C. Again, this data was collected at the Office of Groundwater and Drinking Water at the US EPA facility. Now, after analyzing the purge efficiency and the overall efficiency data at the EPA, the Office of Groundwater concluded that including these measurements within the methodology was not really necessary and wasn't going to be required. This is good news to hear because, as you can tell, it could be quite a tedious and difficult process for some end users. So not including this in newly proposed 524.3 is some really good news. Now, heated purge was determined not to be advantageous for the newly proposed target analyte list as well. The iodinated trihalomethane recovery may be concentrator dependent, and that iodoform was proposed to be dropped as an addition from the target list because of the poor response. As I mentioned earlier, a number of studies were conducted to identify a new preservation scheme. A solid acid preservative for the new method was needed. Maleic acid in combination with ascorbic acid was found to effectively preserve all of the proposed target analytes. Now, most of you may know that maleic acid is used extensively in the food industry as a preservative, also in the pharmaceutical industry as an antioxidant. Now, this monobasic form has a cage-like hydrogen-bonded structure that helps to stabilize the anion through resonance and is a strong chelating agent. This new preservation will provide a much safer alternative than that current HCl preservation scheme. Now, improvements in purge and trap, as well as with GC instrumentation technology, have been developed since that method revision of 524.2. Now, EPA recognized this and actively sought input from instrument vendors, including us here at Teledyne and Tekmar. They asked that we incorporate new ideas and give them information and tools that will help them reduce analysis cycle time, as well as enhance performance without jeopardizing the data quality. They decided that a new method must be structured to include criteria that are going to permit you as laboratories to modify current restrictive portions of the method, helping you to take advantage of the new techniques now available, again, while still maintaining your data quality. So for this reason, EPA investigated the effects of performance of the stratum purge and trap as well as another vendor concentrator over a wide range of operating conditions. Now these are the concentrators, traps, and the standard conditions used for the parameter variation studies performed at the EPA. Now you'll note that the VOCs trap contains hydrophobic sorbents and require dry purging. Now, alternative traps may contain hydrophilic sorbents and may typically not be dry purged. They may also require a secondary moisture control device to help remove water during that desorb mode. Now, use of Tekmar's number 9 trap, that's the new proprietary number 9 trap we designed with the Stratum PTC, along with that instrument, redesign of the moisture control system of that instrument, help to provide the necessary means to effectively reduce this amount of water. Now, the standard parameters investigated are highlighted on your screen in blue, while the operating conditions evaluated are highlighted in black. Note, these conditions cover a wide range of values. This method proposal revision was a lengthy and very well-investigated method revision. So during the next few slides, I'd like to go ahead and present to you the results and the conclusions drawn from these extensive studies at the EPA. Now here you have a plot that compares the average recovery for all analytes investigated. Now this is compared to the standard 440 mils. Here, that purge volume was varied from 40 to 680 mils. Again, it's on two different systems. Concentrator A contained an active moisture control system, while that Concentrator B did not employ moisture control. Again, meaning that system was simply bypassed or not used. Now, the study was conducted with both a VOCarb and a Tekmar No. 9 trap in Concentrator A, and only a VOCarb trap in that Concentrator B. Now this plot compares the recovery for some of those individual analytes as well, compared again to that standard 440 ml standard condition. Now again, they varied the purge volume from 40 to 680 mils. This data was collected with Concentrator B, and this simply shows the VOCarb trap without employment of moisture control management. Now notice here that most of the compounds are recovered completely at around 280 mils of purge volume, except for those water-soluble analytes. And the methyl acetate and T-butyl alcohol are outlined here for you in red. Now the recovery increases progressively with purge volume. Here I've got another plot to show you, and this one compares the recovery for the same set of analytes as that previous slide that I showed you. Again, varying purge volume from 40 to 680 mils. Now this data was collected using Concentrator A VOCarb trap, but here they used the moisture control system. It's important to note here that unlike the Concentrator B, Concentrator A, which was the stratum PTC, displayed a much different profile for the individual analytes. Lower purge volumes favor higher recovery. Higher purge volumes are also detrimental. Now this effect could be related to the quantity of water in the sample path or the moisture control module. Longer purge times are going to result in more water transferred over to that sample path. Now, increasing the purge volume may result in both negative and positive effects on individual analytes, and you can see that from a couple of the previous slides. Now, although cycle time may be reduced for most of your compounds by employing larger purge volume, sufficient volume is necessary for water-soluble compounds and late-eluting compounds. Now, if you notice, this was worse on the trap not recommended by the manufacturer for use with the device, meaning simply that we here at Teledyne Tekmar recommend the use of the No. 9 trap. That's our newer proprietary trap for use with our stratum PTC. And I think EPA studies concluded that that was the case, that No. 9 trap was a better player for the stratum purge and trap concentrator. Now, that moisture control system and or the moisture in the lines are not compatible with the analysis of iodoform or bromoiodomethane. So in the newly proposed target list for 524.3, I would not be surprised if you see that these have been eliminated, as they were proposed earlier as additions to the list. I think because of their poor purge efficiencies and problems with the water management system, that I don't think that we're going to see those on that current list of analytes. Now, these studies investigated the effects of purge gas flow rate and what its effects are on purge efficiencies. Now, the rates that EPA decided to evaluate were varied from 20 to 200 mils a minute. Again, the Tekmar stratum PTC was only purge and trap system capable of achieving the highest flow rates. Following slides are going to present data gathered by varying the flow rate while maintaining that constant purge volume of 440 mils. Now here you have a plot that compares the average recovery for all of the analytes investigated. Again, I just like to mention that this is at, compared to that standard 40 ml a minute flow rate. The purge flow rate was varied, as I mentioned, from 20 to 200 mL a minute on Concentrator B without the use of moisture control. Again, meaning simply that that MCS was bypassed. And this was also varied from 20 to 100 mL on Concentrator A with the moisture control system active. So you can see the comparison of the two. Now, this study was conducted with a multi-phase trap in Concentrator A and compared to a VOCs trap in Concentrator B. Now, this table lists compounds in addition to water-soluble analytes that are negatively impacted by using those higher purge flow rates for both concentrators and two different trap designs. Now, like the water-soluble analytes, these compounds generally exhibit lower purge efficiencies. For example, take a look at the bromoform and the dibromo-3-chloropropane. Although purge volume may be increased in moderation, higher rates should be avoided for compounds with low purge efficiency. Now, this would be even more critical if lower purge volumes were used. So it's important for you to remember this as well as to look for some stipulations and some minimum and maximum guidelines in that new revision because of their varying purge weight studies. So the following slides are going to present data gathered by varying the dry flow volume and comparing it to standard conditions as in previous slides. Now, you'll recall that the standard conditions given earlier are 200 mils of dry purge for Concentrator B, again without that moisture control employed, and 80 mils for Concentrator A, where they employed the moisture control system. Now here, your slide indicates that very few compounds are adversely affected when that dry purge volume is increased to an extreme value of 800 mils. 3 concentrator configurations were examined for EPA's study, and they are shown in the table header here. So the following slides are going to demonstrate that the most compounds benefited from the use of dry purge, even when hydrophilic traps are installed in 2 different concentrators. Very interesting finding. Now, here are the earlier eluting compounds highlighted in red in this plot. Chloromethane, trichlorofluoromethane. They exhibit losses at very large dry purge volumes. These data were collected on a 3-phase hydrophilic trap using Concentrator B without the employment of moisture control. Data collected for some analytes on a VOCs hydrophobic trap using Concentrator B without moisture control are displayed here in this plot. Now, the compounds highlighted in red, bromomethane, methyl iodide, and allyl chloride, only exhibit losses at very large dry purge volumes. Data collected for the same early eluting analytes on a VOCs hydrophobic trap using Concentrator A this time with moisture control are displayed here in this plot. Now, these compounds highlight red. Oh, you know, I noticed I didn't highlight those red. I'm sorry. In red should be bromomethane, methyl iodide, and allyl chloride are adversely affected at an extreme dry purge volume. Again, I apologize for not highlighting those for you, but those that should be highlighted are bromomethane, methyl iodide, and allyl chloride. Now, the data in this plot of analytes eluting in the middle of the chromatogram was collected on a hydrophilic 3-phase trap using Concentrator B without an MCM employed. You can see in the region indicated by the red arrows, and this follows all the way down along all of these plots in the same region. All of the analytes benefit from some dry purge. This finding was unexpected. EPA did not feel that this would happen with the use of a hydrophilic trap. That was a very interesting finding. Now, this slide summarizes the conclusions that were arrived from the dry purge studies that we've just discussed. Most compounds benefit from the use of some dry purge. Now here at Tekmar, that's not surprising news to us. But again, for EPA, it's nice for them to investigate parameters that weren't previously mentioned in 524.2. Now they found that this is true even if that hydrophilic trap is in use without an additional moisture control system, or if a hydrophobic trap is configured with a moisture control device. The newly proposed revisions to EPA Method 524.3 have been brought about by new advancements in purge and trap technology. And now using Teledyne Tekmar's industry-leading knowledge of purge and trap analysis, along with the ability to optimize many method parameters, again, newly proposed for 524.3, will provide all laboratories the tools necessary to achieve those stringent method criteria. And as you remember, in the past, this has been somewhat troublesome with other manufacturers' instruments. Use of our Tekmar Duet high-throughput input interface system is going to allow you the ability to increase your sample throughput, and we're excited that this has been a new proposal for 524.3 for the EPA. As many of you are aware, this can greatly improve your laboratory's productivity and your profitability as well. Now, again, this is an overview of the major differences between 524.2 and the newly proposed 524.3. Note here, there's mention of the possibility of using SEM analysis. Now, no details were provided by the EPA at NEMC or recently. Just a slight mention that they are, again, reviewing the addition of the permission to use SEM mode, and we're hoping that this is the case because you can know that in 524.2 that there have been some troublesome compounds that with the use of SEM analysis will be easier to analyze. And this is a truly exciting find, and I really hope that they do choose to add this to 524.3. Now again, to review, data collected at the Auburn facility has led to this new method revision. Investigation of method parameter optimization has opened the door for 5 key method parameters to be optimized by you as the end user. Again, because of their studies, I'm quite certain there's going to be minimum and maximum guidelines to follow. But just the ability to manipulate these key parameters are going to be so beneficial in your analysis. Now, these include that sample temperature, again, achievable through use of our sample heater. The purge flow rate can be varied, which can be adjusted by use of our mass flow controller, and maximizing your sample potential by varying that purge volume, as well as your desorb time and your dry purge parameters are going to be so helpful. Newly proposed revisions were evaluated by the Office of Groundwater and Drinking Water. Using Teledyne Tekmar's Stratum PTC, which is our purge and trap concentrator, along with our Aquatech 70 auto sampling system. Now that Stratum PTC offers an electronic mass flow controller that I just mentioned. Now this mass flow controller allows for use with either helium or nitrogen. As most of you are aware, helium is becoming quite scarce and expensive, so it's nice to have another gas alternative. Now this patent-pending mass flow controller has the ability to vary flow rates in different modes. Now with the newly proposed changes, this tool will prove to be a very important part of your purge and trap analysis. Has the ability for you to vary your flow rates in different modes is going to greatly increase your sample throughput. Now, that new number 9 trap that I've mentioned several times throughout this presentation and is only available here at Teledyne Tekmar has proved to outperform all other traps investigated during EPA's study, which has been very good news here for us at Teledyne Tekmar. Not surprising, as our earlier investigations of this trap, we knew that this was going to be a better performer for our instrument, as well as a better performer over the VOCarb trap hole. We also have a new U-shaped analytical and condensate trapping system. Now, both of these together are going to provide you with superior retainment of all your proposed target analytes for 524.3. Again, I showed you on the earlier slide the percent recoveries and the percent RSDs for all the newly proposed target analytes, and we did extremely well with that initial study. Both of these systems, the U-shaped trap, analytical, and condensate, are also going to help optimize that water management system, which they've mentioned many, many times in their investigative studies. And both of these are going to also greatly reduce your potential for carryover. Now, much of the data, as I mentioned, presented here today was collected at the Office of Groundwater and Drinking Water at the Auburn facility at the US EPA in Cincinnati, Ohio. Now, I did work with this group of people in the past that did these studies, so I would like to express my extreme thanks for their guidance and support, as well as for their enthusiasm for our Stratum PTC and its role in achieving their proposed method changes. Now, I've provided here for you a quick link. Many of you may be interested in some additional Purge and Track application notes. A complete listing of all of our Tekmar instrument applications are available on our website. So I encourage each of you to take a look at our site. And you should look at it often as a useful tool for many methodologies and technologies and techniques that are out there for all realms of environmental, pharmaceutical, petroleum, even flavor and fragrance arenas. We have so many useful products for a wide variety of different types of applications. So most certainly you should be taking a look at our site as often as you can. Now, if you can, please take a few moments to take a look at our listing here. On your screen, there's some upcoming webinars that are available. I'm sorry, I think I just gave you the wrong screen. Apologize for that. That are going to be presented starting on March 26th. We are going to have an introduction to static pressure concentration. We're going to move over from our current presentations, which have been volatile organic presentations mainly, to our other product line, which will be our TOC presentations. So if any of you are interested in any of these webinars, I encourage you to get online as soon as possible and sign up for those as well. Again, thank you so much for your attendance and participation today in the webinar. I hope that you found this information useful and informative. And I'd like to open up the floor now if any of you have any questions at this time. These questions can be in regards to the newly proposed revision. I'll try to answer those to my best ability possible, as well as if you have any potential questions for the Stratum PTC that was used for these studies, or any of our other Tekmar products for that fact. So I'm going to go ahead and let you open up the floor here. Please feel free to let us know what your questions are. You can, if you're calling in, let us know, or simply type them on your screen. And we have about 15 minutes to take questions now. Thank you.